Hello friends. This video is brought to you by mywayteaching.com.
Let us read the question. Factorize the given polynomial by splitting the middle term and by using factor theorem. Let us first factorize by splitting the middle term. We have a is equal to 6 and c is equal to 5. Then a into c is equal to 6 into 5, that is 30. Then 30 can be written as 1 into 30, 2 into 15, 3 into 10 and 5 into 6. We have to choose that pair so that we can get the sum or difference as 17. Clearly 2 and 15 can give us 17. So let us split the middle term. We get 6x square plus 15x plus 2x plus 5. Group them into 2's. Taking out 3x common from the first two terms and plus 1 common from 2x plus 5. This can be written as 2x plus 5 into 3x plus 1, and they are the required factors. Let us now find the factors of the same polynomial using factor theorem. We can write 6x square plus 17x plus 5 as we take out 6 common, we get x square plus 17 by 6x plus 5 by 6. We are doing this because to apply factor theorem, our general form is x square plus lx plus m. Now let us assume that our px is equal to x square 17 by 6x plus 5 by 6, and the constant term is 5 by 6, which can be written as 1 into 5 by 2 into 3. So the factors would be 1 by 2, 1 by 3, 5 by 2, 5 by 3 and 1, and they can take signs positive or negative. So now we have to find P of A equal to 0 and P of B equal to 0. Then we will have the factors of Px. Now by trial method, we find the value of P of half. On substituting the values and solving, we find that P of x for x equal to half is not equal to 0. So let us move on to next number. Let us find P of 1 by 3. Again, it is not equal to 0. Let us check P of minus 1 by 3. We find that the answer is 0. That means x minus minus 1 by 3 is a factor of px by factor theorem. Now let us check for p equal to minus 5 by 2. On solving, we will get p of minus 5 by 2 equal to 0, implying that by factor theorem, x minus of minus 5 by 2 is a factor of px. And now we can write a polynomial as the product of its factors, that is x plus 1 by 3 and x plus 5 by 2. This can be solved further and we can get 3 as LCM, 2 as LCM, and solving further, finally we get two factors as 3x plus 1 and 2x plus 5. Let us read the question. Factorize the cubic polynomial. Let us denote the given polynomial by px. To solve such a polynomial, our first step is to at least find one root of this polynomial using factor theorem. We can see that the constant term is 120 and the factors of 120 are plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 8, and many more. Let us find px for x equal to 1. We find that p of 1 is equal to 0. So by factor theorem, x minus 1 is a factor of px. After this step, there are many different ways of doing the question, but let us do the simplest one. Let us divide px by the factor that we have already found out. On division, we get quotient as x square minus 22x plus 120, and we already knew that remainder will be 0. Now substituting in dividend is equal to divisor into quotient plus remainder, we get given polynomial equal to x minus 1 into a quadratic polynomial and remainder is 0. Now we can split the middle term for this quadratic polynomial and further find the roots of or the factors of the cubic polynomial. A into C is 1 into 120, that is 120, and that can be written as 12 into 10, whose sum will be 22. So let us proceed further. Since we want a negative sign, and minus 12 minus 10 will also give us minus 22. So we take minus 12x minus 10x. We have split the middle term. Now taking x common from first two terms and minus 10 common from the next two terms, we get the following expression, which can be written as x minus 1 into x minus 12 into x minus 10. Note that since it is a cubic polynomial, it has three roots, that is x minus 1, x minus 12 and x minus 10.